Alright, well, I've been doing some of my own work trying to figure out how to make some sort of mechanical way of getting alternating current from direct current or from DC power. Uh, I've been going through so many inverters, electrical inverters, that don't seem to be very reliable, even the you know somewhat expensive ones. So I decided to figure out how to do it with some sort of mechanical setup that doesn't have any circuitry in it that can cause the entire apparatus to fail. And uh, in my research, I found out that back in the day they had these oscillators. Like, like here's one I'm going to be using for this little demonstration, and they originally were made way back in the day when electricity was still kind of being fundamentally used, and they made these school bells or fire station bells. See how they have these coils here that attract this little arm that has the little metal ball on it. But the way they turn the DC power on and off is there's usually another little connector. I have it over here. This thing supplies the little contact screw that makes contact to the frame for the coils. Then I have the frame right here connected to this coil, and the other coil, and they're connected together right there, and the other coil is going to be connected to this. I have just a DC adapter right here for this demonstration, because 12 volt battery power isn't enough for to get a substantial amount of current. I can only get about 45 to 50 volts AC with just 12 volts. So this is a 24 volt adapter over here, and with this 24 volt, I'll go ahead and show. See, what I have here is I have the contact screw connected to a transformer, and the other lead of the transformer is going to be connected to the other end of the power adapter. And the other end of the positive, or the other end of the power adapter, the positive end is going to be connected to the coils that go through the coils, through the frame, attract the metal to the coils, and it's going to break contact to the transformer wire that I'm going to connect right here. So there's going to be pulsating DC going through the transformer, and I have the voltmeter over here for and I have it on alternating current volts. So we'll go ahead and make contact here like this. So you can see it's getting about 65 volts AC. So I can go to higher DC volts than this. I've gone to 36 and 48 so far, but what happens is the coils start to kind of get a little too hot, and where the contact breaks here, where the arm breaks and makes contact to the DC power, it starts to like overheat, like the contact screws start to disintegrate. They start to react with the air, and they start to disintegrate into smoke or whatever. They start to combust basically with the contact with the air. So my solution, so I can be able to put more DC power than just 24 volts, I want to be able to put maybe over 120 or about 120 volts pulsating DC. Then it'll be the proper amount for the transformer to step it up to either 220 or 240 or even higher. But the heating problem with the oscillator seems to be what's holding me back right now. And I came up with the solution to use. I'm going to use this glass lighting dome here, and what I'm going to do is I'm going to set it up so I can suck out all the air of this thing with the oscillator inside it. So there'll be a vacuum in here, so combustion won't, or the the disintegration of the contact screws here won't react with any air, so it won't happen. So I'll be able to hopefully solve the heating problem with higher voltage of DC through the oscillator, because it seems like the heating problem seems to be what's the only issue. If I can fix that problem, then I can put almost any amount of DC power into the oscillator that I want and get whatever AC power I want to get out of the transformer. And it kind of surprises me that there's no there's nothing in the history books about this, especially when DC was the only power supply around. Back in the day when nobody believed that AC power was possible, history is not quite clear if people thought it couldn't be possible, because they made it very clear that an AC motor they thought was impossible. They called it a perpetual motion machine, quote unquote. But I think they also had the same outlook on AC generators as well. I don't think they could. Most people believed probably back in those times that you couldn't get AC power from DC power as well. They only had DC dynamos and no AC motors or no AC generators. But they did have these oscillators though. They started using these type of oscillators for wireless telegraphy. They would have what's called an induction coil, which is pretty much the same thing as this oscillator, except it's just one gigantic coil, and it has another coil wrapped around it, the high voltage coil. So the induction coil that's acting as the on-off switch for the DC power acts as a step-up transformer at the same time, and makes a high voltage AC that creates the AC spark that they required for their wireless telegraphy transmitters. And I'm just surprised that I can't seem to find any sort of apparatus in history that uses these oscillators with a transformer to make pulsating DC into AC power, because that's basically what I'm doing here, and this is what I came up with to get AC power from DC power some sort of mechanical way. They do have what's called rotary transformers from DC to AC, but those have to have something that's spinning like a dynamo, and the amperage on those aren't very high as well. But with this one, this is putting about 1.5 amps of 24 volts DC, and I'll be getting about almost 70 volts out of the transformer AC. That's probably about probably around an amp at least, I'm guessing. I don't know what the amps is, what kind of amps is getting AC, because I have just these tiny wires going to it, to the voltmeter. But you can see it's getting about 65, just between 65 and 70 volts AC with 24 volts DC from the power adapter there. So well, that's basically what I've figured out so far, and it seems like if we can keep the oscillator going, then there's no real reason why you can't utilize the AC power that you get out of the transformer. I'm not sure what kind of effect a load would have trying to tap power out of the AC transformer on the oscillator. I'm guessing there will be some kind of load on the oscillator too, causing the frequency of it probably to go down. So I'm guessing when I finally do get the oscillator inside the vacuum glass dome over here, that the frequency of the oscillations will determine the amount of amperage I get with the transformer and AC power. Pretty much if the oscillation slows down over here, I'll probably get more amps but lower volts. But if the oscillation speeds up over here, I'll probably get more volts but less amps when it comes to the AC power. But that's just my my best guess for now. And it'll be nice when I finally get an air pump and a setup for this glass dome here, so I can do the experiments with the entire oscillator here inside a vacuum, so I can put a substantial amount of more of DC power into it and not have to worry about the heating problem. But there you go, there you have it. There's my progress in research and experiments with these DC oscillators here, because I'm completely over electrical inverters. I've gone through about 15 of them, and they've all had, you know, something that fails. Like one of my pet peeves about them is the little alarm that comes on when you have low voltage. It goes like beep, and all I did on one of the inverters was take that alarm off, and the whole inverter wouldn't work anymore. And I tried to put it back on, and it still wouldn't work. So after that, I was just like, you know what? Let's find a mechanical or some sort of basic way of doing this. And with my research into history, it seems like nobody has ever tried this. There's no history on somebody using an oscillator with a transformer to make AC power from DC. They've always just used these with wireless telegraphy and school bells and fire bells like that over there. And nowadays they use them with tattoo machines, you know, automatic skin tattoo machines. They need something like this that'll I guess oscillate the needle back and forth into somebody's skin. But I want to use it for DC to AC mechanical inverter power, and we'll see how far we can get once we get the thing in the vacuum and get some real DC power pumping and going.